Back, this is A-level Computer Science 9618 paper 4, and today in this video we are going to understand about binary tree with array. So in the previous video we discussed about, we try to implement binary tree with OOP, but now we're going to do this with array, and this is also the part of your syllabus. In the previous video we discussed about linked list with array, but now we are starting with binary tree with array. Okay, so let's begin. So there are three things to understand. Number one is add item, print, find. All the or maybe just two, find and add item. So how do we implement this? We have this array. Okay, so we got the column for the data, we got the column for the left pointer, we got the column for the right pointer. So this is how it's going to work. Okay, so for example, I got this is the root, this is the root, this is the root, the root node, this is the starting point. Okay, so 27, the left PTR is 1, which means pointing to this, and right PTR is 2, which means pointing to this. So it will look something like this. Okay, this is how the binary tree is created. And whenever we try to add an item, we have to follow a rule that whenever we try to add, for example, I got 27, and then I just put another one, 19, and now I'm going to see whether it is less than or greater than. Since it is less than 27, so it will go left. If the data is less than the root node, then it will go left. If it is greater than, if the data is greater than the root, this is the root actually, this is the root, then it will go right. So I got 19, so it will go left, so 19. Then after that I got 36, so 36 it's greater than, so it will come here. And then I got 42, greater than, so it will come here, 42. Okay, and then if I put 16 less than, so it will come in here. Okay, so in this same sequence I just created a whole binary tree. This is how it works. This is how you try to add an element, a data into the binary by comparing with the root. And also, for example, 16 is compared with this, it will go forward, and then it is also compared with this, and it will keep on comparing until it reaches to the point where it is null, where we have minus, where it is pointing to null. Okay, so this is how you create a binary tree. Now let's see the code. So first of all, what I've done here, I have created a class for the node. So each node contains each node contains a data, a left pointer and a right pointer. So I've created an array of this node. I've created an array of this. Okay, also I've created an array, and then I just call the constructor. In the constructor I have initialized the array, where I'm creating a new, I'm calling the constructor, and I'm initializing the left pointer and initializing the right pointer. So in this, whenever the binary tree is initialized, it will look like this, because it is pointing always the initialize, the free node, the empty nodes will be pointing to the left side. Okay, and to the right it will be null, pointing to this, left, and then it will be -1. Okay, so we got two things. Number one is the root, number two is the free PTR. Right now the free PTR is 0. This is the free PTR, and the root is -1 because we haven't created any root yet. Okay, accordingly, now moving forward, after initializing this, we will go forward, and then we need to create this function at item. If free PTR is equals to -1, which means there's no free nodes, everything is fully packed up, every node has been used. Okay, otherwise if there is, then we can insert an item into that node. So current free node is equals to free PTR. We are getting another free node. Okay, current free node, free PTR. Right now free PTR is 0. Okay, current free node, it is saved in current free node. Then free PTR, the free PTR is initialized. Okay, updating the free PTR. So it will, for example, I have taken this. After taking this, then this will be the new free PTR. Okay, so I have just updating the free PTR So this is what it says. So free ptr is equals to binary tree free ptr dot left pointer. So it's giving the, then it's giving the index, it's saving here. Now it's pointing to the left, the the next one. If root is equal to -1, if there is no root, if this is the first time that you are adding an item into the binary tree, if root is not initialized, I mean if it is null, then first of all we're going to create a root. If root is not created, then root is initialized first. Okay, then we're going to just say root is equal to 0. If root is equal to 0, this whole thing is coming in here. This whole thing will be skipped. I mean the root is being initialized to 0, which means the first node is being created, and the current free node is equal to left pointer is equal to -1, right pointer is equal to -1, and data data is equal to data. And so we have created a first node, a root node. But supposing that we have already have a root and we need to put another item, the second item. So if root is equal to -1, root 0, otherwise else temp is equal to root, taking the root and storing in temp. While temp is not equal to -1, now we're going to put in a loop. So putting it into the loop, old ptr is equal to temp. We got the old ptr. Binary tree is okay. While temp is not equal to -1, temp is equal to old ptr. Binary tree temp dot data is, if binary tree dot temp dot data is greater than data, then it will go left. Okay, and this one and this and temp will be updated. Temp is updated. Okay, if binary temp dot data is less than data, then it will go right, and temp again will be updated. So it will be updated. So it will keep on going while temp is, until temp becomes -1, and it will become -1 when it will reach the end, in any one of these. After reaching the end, we're going to use some condition. If go left, if that if that data is to be put onto the left, if go left, then binary old ptr. So for example, you got this node and either it has gone left and there is -1, and or either way it has gone right, it's -1. So if that data is going left, and we need to put in here something, right? So binary old ptr, so this is the old ptr. Binary old ptr dot left pointer is equal to current free node. So now we are updating this pointer into the current free node. Okay, if the data needs to go right, then we're going to update the current update the right pointer with the current free node. Okay, pointing to the current free node, After pointing it, we then try to create the dead node. Okay, so this is how it's working. Moving on, and then we got the find method. Okay, so it's the same thing. While temp is not equal to -1, and while temp dot data is not equal to search data. If it is greater than, it will go left. It is right is less than, it will go right. Okay, and either way, while time is not equal to -1. Okay, so this will be this condition will be proved, because the temp will be equal to -1, then it will come out from the loop. And after that, if temp is equal to -1, then sorry, not founded. Else if binary temp dot data is equal to search data, then data is founded. Either one of these will become true, that either the data has been founded or it has run out. The temp becomes null, either one of them. Okay, so this is find method, and then we got the print method, which is very basics. And then we have this is how you create it. Okay, and these are null. 0 is the root, data is founded, and this is binary tree.